Hello and welcome back to Zig's Math Lessons, Lesson 2 in our introduction unit to calculus. Today it's the slope of a tangent to a curve. In grade 9 we studied the slopes of lines. Consider this line. This line has a constant slope. No matter where you are on this line, the slope is still the same. It's mx plus b, and the slope is m. But curves are different. Depending on where you are on this cubic, it has different slopes. So the slope itself is a function of x. Let's take a look. The slope of the cubic is considered to be the slope of the tangent at a given point. For example, we can see that the slope of this tangent line, and a tangent is a line that goes by and touches a curve at only one point. The slope of this tangent line changes as I move the point of tangency along the curve. You can see that now the tangent slopes down, now the tangent slopes up. So depending on the x value, the slope of this tangent changes. And so the slope is itself a function of x. The slope of a curve is a function of x, as opposed to grade 9 where the slope is always m. Now the slope depends on what x is. One of the primary problems that calculus addresses is to find the slope of a tangent to a curve at a given point. So if we consider this blue line here to be a curve, a function of x, and we pick a point P here, x, f of x, right there, and we seek the slope of the tangent there's the tangent line going by, we can approximate that by picking another point along the curve, say Q, x plus h, f of x plus h, and taking that point Q and sliding it along the curve and seeing what happens to the slope of the secant line. Now the secant line goes through and touches the curve at two spots, Q and P. But as Q slides along this blue line, we'll see that the slope of the secant becomes closer and closer to the slope of the tangent. So one of the approaches of calculus is to slide this point Q along this curve, and h, which is the horizontal displacement between P and Q, h will become smaller and smaller. Now let's see this in action. As h becomes smaller and smaller, Q slides along this curve, and as Q slides along this curve, the slope of this line, the secant line, approaches and gets closer and closer to the slope of the actual tangent at point P. We can see that h is getting smaller and smaller. We can see that the secant line, which is the line through the 2 points P and Q, the slope of that is getting closer and closer to the slope of the actual tangent at P as Q approaches P. As h gets smaller, h getting smaller, getting smaller, getting smaller. Approaching zero, in fact. And once it actually touches zero, then the slope of this secant line will actually be the slope of the tangent. And this is going to be our approach. Let's consider the curve y equals x squared. This is a function that we're very used to. It's a standard parabola, y equals x squared. And look at the point 2, 4. This is the point 2, 4, which is definitely on the curve y equals x squared. And let's consider a q here, somewhere to the right, displaced to the right. How far? Displaced to the right by h units. So the x value at q must be 2 plus h, because it got displaced to the right. And of course, the y value, being x squared, must be 2 plus h squared. Now we can find the slope of the secant PQ algebraically. Finding the slope PQ algebraically. Well, here's our point P, here's our point Q. Let's find our slope. We know that slope is y2 minus y1 over x2 minus x1. And there's our y2, and there's our y1. And there's our x2, and there's our x1. So we can just plug them in, and we can get the slope when x equals 2. There it is, y2 minus y1 over x2 minus x1. Now the algebra part is pretty easy. Squaring a binomial, 2 squared, then double the product, h squared, there's that minus 4. And this 2 and this minus 2 offset each other, leaving behind just h. And the 4 here and the minus 4 will offset each other, leaving behind just 4h plus h squared. And we can common factor in the numerator. And we have some convenient canceling here. You can cancel factors. And we have the slope at 2 being 4 plus h. Now you can well imagine if h was getting smaller, like in the demonstration, the slope at 2 would actually be the number 4. So let's do this in general. The general case. So y doesn't equal x squared, y equals f of x. And f of x could be sine x or cos x. It could be a cubic or a quartic or any function at all. Y equals f of x. So let's consider the point P, a f of a, an arbitrary point on the curve. And let's pick another point on the curve called Q, which will be a displaced to the right by h units, so a plus h, and then of course the y value has to be f of a plus h. Now if this is the case in general, now we can find the slope in general, finding the slope PQ algebraically. Again, the slope will be y minus y over x minus x, so the slope at a will be y, which is here, minus y, which is here, so it'll be f of a plus h minus f of a, over x, which is here, minus x, a plus h minus a, this. Doing the math on the bottom, a offsets with minus a, leaving behind just that, and this brings us to our first formula for calculus class, the slope of a function at a f of a. In general, the slope. It's this. The slope at a is the limit as h approaches 0. That's how this is said. The limit as h approaches 0 of f of a plus h minus f of a over h. And I put it in a box, and I suggest that you watch these videos with pencil and notebook handy, and that you write down in your notes what goes in the video. And we have here our first formula. It's a pretty important one. The slope at a point A is the limit as h approaches 0 of f of a plus h minus f of a over h. It's the slope of a tangent to a curve at a point where x equals a given number. Now we'll do 3 examples of this for exercise. Example, find the equation, not just the slope, but find the equation of a tangent to a curve, and it looks like it's a parabola that opens down, at a point where x equals 5. Okay, solution. We have a formula for this, just presented, and it's necessary to prepare. We must prepare to sub into this formula. This is the formula we just considered, and it would be more convenient to figure out f of a first and f of a plus h first, and then take that result and sub it into this equation. Oh, it's possible to not do that, but it can get confusing. So let's find f of a. Now here in this case, we're interested in when x equals 5, so a is going to be 5. So we need f of 5. Plug it in, do the math. We've got f of 5 is negative 14. Now f of a plus h will be f of 5 plus h, because a is 5. Plug it in. Where? Plug it into the formula given, and do the math. Now we're going to have to square a binomial and do some arithmetic here, so it'll be negative, and then square the binomial, first term squared, double the product, last term squared, and so on. Expanding in here, we got 15 plus 3h minus 4, doing the math. See, this is way easier to do if you prepare first. This is the prep. Collecting like terms, and we have f of 5 plus h. So we have f of 5, and we have f of 5 plus h, and we're ready to take these and plug them into this formula. You see, we prepared. to sub into this formula. So let's do that now. There's the formula, there's the prep work, and now f of a will be f of 5. And we know what f of 5 is, it's negative 14, and we know what f of 5 plus h is, it's all of this. So plug all of that in. Plugging into this formula, notice the form. You must get this form right. M of 5 equals the limit as h approaches 0 of an expression equals the limit as h approaches 0 of an expression. This little notation continues in this spot, not to the left of the equal sign, but just to the left of the expression, equals the limit as h approaches 0 of an expression. Simplifying that expression, negative and negative is positive. Negative 14 plus 14 offsets. Leaving that behind, common factor, take out the h. Now, the h's cancel, and we do a process called take the limit. Notice it says the limit as h approaches 0 of an expression equals the limit as h approaches 0 of an expression equals the limit as h approaches 0. You keep saying this every single time. Equals the limit as h approaches 0 of an expression equals the limit as h approaches 0 of an expression. And then when you quote unquote take the limit, then you stop saying that and you sub in 0 for h. This h will become this 0. Plug it in. And of course, the answer here is minus 7. And so the slope at x equals 5 is minus 7. Now, we were asked for the equation of this tangent. So we have a point, 5 minus 14, because we want the tangent at the point when x equals 5. So the point is 5 minus 14 we can get from here. And the slope is minus 7 we can get from here. And now it's grade 9 math, because we have our point, we have our slope. It's y equals mx plus b. And there's the equation. I put them all on a graph so that we could see what we just did. Here's the curve, which I labeled y equals negative x squared plus 3x minus 4, the blue line. There's the point, 5 minus 14. And we found, using calculus, the equation of this tangent line. It's the red line. And there it is, y equals negative 7x plus 21. And we could sense that as this goes way up there, it has a y-intercept of 21. Let's do it again. Find the slope of the tangent to the curve at the point where x equals 3. Solution, we have a formula, but we must prepare to sub into the formula. There's the formula, so we'll need f of a, and we'll need f of a plus h. A is 3 here, because we're interested in the point when x equals 3. So f of 3, plugging in 3 and doing the very simple math. F of 3 is 5. And now we need f of 3 plus h. F of 3 plus h means plug in 3 plus h for x. So x became 3 plus h. X became 3 plus h. And doing the pretty simple math. So we have f of 3, and we have f of 3 plus h. And we have our formula, and so we're going to plug those into the formula. So the slope at a is limit as h approaches 0 of f of a plus h minus f of a over h. And a is 3. So slope at 3 is the limit as h approaches 0 of f of 3 plus h minus f of 3 over h. And you can see that we're very happy that we did some prep work, because now we can just plug this stuff into this formula, because we did the prep work. This equals the limit as h approaches 0 of f of 3 plus h. Plug that in. F of 3, plug that in. Now we have to simplify this expression. And that means you're going to have to subtract fractions with a common denominator. Multiply out the numerator and collect like terms. Now this h is actually h over 1, so it'll be times 1 over h, because when you divide by a fraction, you flip the fraction and multiply. And of course, 15 minus 15 vaporized, and we've got 3h minus 5h is minus 2h. And those cancel. At this point, we can take the limit. We can take the limit now. So we can sub in 0 for h, and we've got minus 2/3. So the slope of the tangent to the curve at the point when x equals 3 is negative 2/3. Again, I've graphed all of this. Here's the graph of y equals 3x plus 6 over x. That was the curve in question, and we were interested when x equals 3. What's the slope there when x equals 3 at that point? So the tangent would be going by and touching it just once, and we found that the slope of the tangent was negative 2/3. Let's find out if this is true. There's the tangent. Let's pick this point and see. Drop 2, run 3. Yes, the slope is drop 2, run 3. Yes, the slope is negative 2/3, which we found using calculus. Let's do a last example. Find the slope of the tangent to the curve y equals root x, which I've graphed here, at the point when x equals 16. Now there's 16, so there's a point, and I wonder what the slope is there. So that's what calculus is going to tell us, the slope. It looks like it's a positive slope. The tangent would be positive there when x equals 16. And it looks like it's sloping up very gently. So a small positive number is what I would expect as an answer here. Find the slope of the tangent to the curve at the point when x equals 16. Okay, solution. The solutions are always the same. Prepare to sub into a formula. There's the formula. And a is 16. So we'll need f of 16, and we'll need f of 16 plus h. So this is pretty easy. F of 16 is, well, plug 16 in here, so root 16, which is 4. And f of 16 plus h is just root 16 plus h, because we plugged it in right here. So we've got a couple of things that we're going to use to sub into a formula. The solution method is always the same. There's the formula. There's our prep work. Plug them in. F of a plus h, well, f of 16 plus h, and f of 16, because we're going after m of 16, the slope when x equals 16. We did our prep work, so f of 16 is, this number is 4. And f of 16 plus h, we can refer to this. It's a square root of this. And look at this. We have to do something, because you can't just take the limit. I'd like to take the limit right now and be done with it. But I can't plug in h equals 0, because that's putting 0 into a denominator. And you can't have 0 in a denominator. So I can't just plug in 0 for h. This is a common error made by calculus students. You can't do that yet. You can't take the limit. So we'll say m of 16 equals the limit as h approaches 0 of an expression. Equals the limit as h approaches 0 of an expression. We have to do something to this expression before we take this limit. And what we do is we rationalize. So we'll multiply top and bottom by the conjugate. So root 16 plus h plus 4 over root 16 plus h plus 4, like on the previous video. And what we have here is a difference of squares. So when we multiply top times top here, we'll get a difference of squares. So it'll be 16 plus h minus 4 squared. So it'll be 16 plus h minus 16 in the numerator. And on the bottom, in the denominator, we'll just go h times what we see here. 16 plus root 16 plus h plus 4. Notice every line equals the limit as h approaches 0. Equals the limit as h approaches 0. Equals the limit as h approaches 0. Equals the limit as h approaches 0 of this. Now 16 minus 16 vaporize. h over h cancels, and now I can take the limit, because it's not, the denominator won't be 0 anymore. It's like a miracle. Sub in 0 for h, and do it mentally. This is now root 16, which is 4, and 4 plus 4 is 8, and this canceled to 1, so it'll be 1 over 8. And so the slope of the tangent when x equals 16 is that positive small number we predicted, 1 over 8. Let's go back to our graph and have a look. There's the point 16. Here's the tangent that line, and we've used calculus to determine that the slope of that tangent was an eighth. Let's see. Let's pick this point here and rise 1, run 1, 2, 3, 4, 5, 6, 7, 8. So from this point, you rise 1, run 8, and that's the slope of the tangent to the curve. I'm not Ziggleby Biestunk, but thanks for watching. If you liked it, leave a like. If you like the content, please subscribe. And the comment section is an excellent spot to ask some questions. So ask some questions if you have them, and I'll be happy to answer them.